We are just straight up doing word problems in 5.8. Okay, so homework. So we have basically done everything we've needed to do to set ourselves up to do word problems. So again, we have said that trig functions serve two purposes. What are the two purposes we talked about mainly? It has to do with number one. First of all, trig functions help us solve the right triangle, right? So that if I give you enough information, I should be able to tell you everything else, right? So here is a perfect example. And this example really gives the power of the angle. The angle tells us tons of things about a triangle, right? So just given the fact that we have a 90-degree angle, if I give you another angle on one side, I'm able to tell you everything else, right? So this test really is, or this homework and the test is really going to give us an idea or give us, let us know the applications of trig functions, okay, in terms of solving the triangle and in terms of being something that helps model waves. On the final, you will be asked one of the problems in this section, so be on the lookout. I may circle it for the star by it in terms of one of the questions that are on, that actually is going to be on everybody's final across the board in terms of what we want you to know about trig functions. All right, so here we got a right triangle. I'll copy this on a new page. New. Again, the whole point of trig functions, one of the major applications is relating the sides of a triangle to the angles of a triangle. They're telling you that A is 31.8. I should also let you know that this is going to be the standard way in which we label triangles, right? That the lowercase letters will be the lengths of the sides, the capital letters will be the angles. Okay, capital letters will be angles, lowercase letters will be the lengths of the sides. Say it again. So the labeling, the standard triangle is going to be capital A, capital B, capital C are all the angles. Little a, little b, little c will be all the sides. And little a will be opposite capital A, little b will be opposite capital B, and little c will be opposite capital C. And as you know, the real game plan is to make sure that C is no longer 90 degrees. Right? So right now, this is going to be pretty straightforward because I'm giving you the 90-degree angle every time. But the chapter 6 is going to be about what happens if that triangle is no longer 90 degrees. Can we still find every angle and every side? But for the moment, we got this. It's good. So we need a trig. So I like to label this thing. This thing's 24, right? And now it says we should have enough. Okay, well, angle B we should be able to get, right? I got a 90-degree angle. I got a 31.8 degree angle. How would I find capital B? 121.8. They all have to add up to 180, right? So then B is 180 minus 121.8. That's the remaining amount. Ooh, 59.2. That's right, 58.2 degrees. Questions there? Keep in mind, if you got two angles, you automatically know the third one. You have to add up to 180. Need to find side A. Right? So if only we had a trig function, so this is begging for a trig function, right, that will relate the opposite side to this angle that we know and to some other side that we know. And it's going to be tangent. Okay, so A, well, let's write the equation. We know that the tangent of 31.8 degrees, make sure we're in degrees, is the opposite side, little a, over 24. Little a is 24, the tangent of 31.8. It wants you to round to the nearest hundredth. That's all calculator. This in the TI is pretty easy. It's 24 tangent parentheses 31.8. That's just, it literally goes in like that.
I got a question, Professor.
Thank you.
When is the exam? Next Wednesday?
So yeah, I'm gonna open it up probably tonight or this weekend, and it's due next Friday at midnight.
The exam?
Yeah.
All right.
Practice exam opens tonight at 10. Questions about that? That's little a. Little c, then we can find it in a couple of ways. Once we have, well, that's right, so we could use the trig function, but then once we have two sides, we're all ready for the Pythagorean theorem. It's up to you, right? So then, what is this number here?
9.70.
9.7? Someone else verify that? Can I get a second witness to that?
That's correct.
That's correct. Excellent. Excellent. 9.7. Little c, now we know that a squared plus b squared is equal to c squared. We know b already was 24. A is 9.7. 9.7 squared plus 24 squared is equal to c squared. And so c is equal to the square root of 9.7 squared plus 24 squared. All right, so once you have two sides, you can get the third angle by the Pythagorean theorem, much like once you have two angles, you can get the third angle because they add up to 180 degrees. Of course, you could have used a trig function. You could have said that it's going to be the cosine. The cosine of 31 degrees is 24 over c. Let's go ahead and do that if we wanted to. I'm sorry, go ahead.
When answering it on the format, do you have to include the parentheses?
Wait, here?
The
Wait.
answer,
Wait, where?
the C, and
Oh, see, you need to figure out what this is. You need to figure out what is that number. Has someone put that in yet?
25.89.
25 point. They what, 100th? 89? Oh, why'd you give me a to the? So it was 9.70?
Yes, that's what I mean.
Okay, yeah, 9.7. Okay, great. Okay, so 25.89 and 9.70. Yeah.
What about letter A?
Capital A or lower A? This A right here?
Oh, okay.
Yeah, it's all calculator at this point. There should be no parentheses. You should flat out put a number to two decimal places. Yeah. That's super quick. Let's go ahead and verify that if we had used cosine, we better get the same thing, right? So the cosine of 31.8 degrees is equal to the adjacent over the hypotenuse, right? So switching these two, c is equal to 24 over the cosine of 31.8. Some people may prefer to do it this way than to do square roots and all that other stuff, right? 24, you get the same thing? Put it in the calculator, TI 24 slash cosine 31.8. Same thing, roughly. So you get 25.89. Thank you. Go ahead.
For the 9.70, is that supposed to be on radians or degrees?
Oh, so this is a great question. So you use a trig function here, right? And so it's when you do the tangent of 31.8, it's this 31.8 that is in degrees. That's in degrees because we're in the context of a triangle. So when we're in the context of a triangle, all these angles are degrees. Yep. 25.89. What evidence do we have that suggests that this might be right? How would I know that when I got if I got 17, that would have been wrong?
You add them all up, right?
I could have, but just by looking at it, how do I know 17 would have been wrong? What do I know about C? C is the longest side of the triangle. It better be longer than 24. The answer better be more than 24. Okay, so if you do something, you get something less than 24 for C, then you've done something wrong because C is opposite the largest angle and therefore it has to be the largest side. Okay. Yeah, please.
How did you know it was tan?
Oh, that's a great question. So the challenge that we have is that I'm going to give you, I thought we drilled on this, but just in case we haven't, let's super quickly do this. Opposite, adjacent, hypotenuse, right? Cosine of theta is the adjacent over the hypotenuse. Sine is the opposite over the hypotenuse. And tangent is the opposite over the adjacent, right?
Yeah.
Okay, and so what's going to happen is I'm going to give you some angles and some sides and leave some other ones out, right? So that I'm going to put some values here, and now you're supposed to be able to tell me which trig function is going to relate them, right? So the one I just did, I gave you the angle was, and I don't care, and I'm going to change it to something else, like 20, right? And I'm going to tell you that this is x, and I'm going to tell you that that's 15. So then you have to, first of all, you're going to look at this and say, if I'm looking for x, and I know the angle and I know another side, then it's the trig functions here that relate angles with sides. And so there is a trig function that will relate this angle with its opposite side and the side that's adjacent. What trig function is that? Exactly. Right, so that's the analysis you have to do. You literally have to say, well, I literally say the sentence in my head every time. I have this angle, I'm looking for the opposite, and they also gave me the adjacent. They gave me the angle, I'm looking for the opposite, they gave me adjacent. I must be using tangent, right? And then I fill in the stuff that I know, and just naturally the thing I'm looking for just shows up, right? So that's the challenge for the first two, and that's going to happen on the test, as you'll see, right? I'll give you some triangles, some stuff will be filled in, and the only thing I'm grading on, right, is that you know which trig function to use in which case. Is that okay? Other questions about this? Thank you for your question. Butler, you had a question, right?
I believe that the numbers that we were using were in radians.
Yep.
It is in radians, it's not in degrees.
Yep. Made a mistake there.
Feel free to tell me at any moment.
Well, you're.
I was just rolling along. Okay, no. But if something's wrong, so okay, so what's tangent?
I kept doing it like 5 or 6 times.
Thank you. 14.80. 88. All right. What's C then?
It is 28.24.
Excuse me. It's what?
28.24. Yes, 28.24.
Okay, great. All right. Yeah.
So he changed this.
Yeah. The someone didn't put this in the right mode, right? So this 31.8 needs to be in degrees.
You have to go from degrees to radians and back to degrees. Or...
So this whole thing should be in degrees.
Oh, okay. It was in radians before.
Someone put it. Someone had their calculator in radians. Yeah. Okay, no, it sweeped everybody, the radian issue. Feel free to speak up a little bit louder, brother. You knew this the whole time.
Yeah, I don't want to say no to that.
No, I know. Why not?
I did too, but I didn't want to say anything.
What is wrong with you people? This is a community of learning, right? So, yeah, if something's wrong, yeah, then we've got to say it. Yeah. Mathematicians would never stand for this. Mathematicians are like, no, that's wrong, right? And we don't take it personally. Yeah. What's great about being in the South is that people are nice like that. Up at the North, they were just like, you're messing up. This is supposed to be in, you know what I mean? So it's love either way, right? This is down here. People are so nice, like, is that right? I'm not sure. You okay? Okay. I'll take any other questions about this. So we got B, A, and C. We're going to turn up the speed speedometer now. Okay, so then here's another one, and another one. All right, so we've got B, they told us, is 16.7. They're switching it up on us. That immediately makes this 90 plus 16.7, gets us this next angle pretty quickly, 106.7, 73.3. And now, what trig function we're talking about? If it's in reference to B, right? So let's just label what we have. We got 34.5, right? And do you have anything else?
Angle.
We're already looking for A, right? So then now I got B. I got the opposite side, and I have the adjacent side to B. What trig function is that? Tangent. The tangent of 16.7 equals opposite 34.5 over the adjacent. Right? The off the record, the street version is that if we've got a triangle and the hypotenuse is not being given to you, then it's tangent. If they don't give you the hypotenuse, you're using tangent. That's the street version. When you switch these, A equals 34.5 over the tangent of 16.7, all calculator. Round to the 2 decimal places. The TI goes 34.5 slash tangent, parentheses, 16.7 in degrees. Right, so the idea is the same. I might not roll through all of these. Some of these might be interesting. Oh, I got to do 3. They don't give us any angles. That's a lot of fun. What you got?
114.9.
2 decimal places? 114.99?
9.
Okay. So let's go ahead and find C using the trig way. C is the hypotenuse, so, and I have the opposite. What trig function uses the opposite in the hypotenuse? The sine of 16.7. Let me move this somewhere else, because I'm about to snatch this to another page. The sine of 16.7 is equal to the opposite, which is 34.5 over the hypotenuse, which is what I'm looking for. They switch. C equals 34.5 over the sine of 16.7, and it's all calculated there. That should be the largest number on the triangle in terms of the side. It should be more than 114.99. And it's roughly proportional, right? Again, the bigger the angle, the larger side. So A was already pretty big, right? So that's a big angle, because 90 degrees is already pretty big too. All right, so whatever you get, I'm gonna leave that to you. Let's do 3. Got a right triangle. I'm going to give you 2 of the sides. Of course, if I give you 2 of the sides, you can get the third side. So I'm going to give you all the sides. Give me all the angles. Okay. So let's label a little bit. So this is 28. I'm sorry, this is 28.8. This is 51.2. Let's Pythagorean theorem this thing out just to get B immediately. B squared plus A squared equals C squared. B squared plus 28.8 squared equals 51.2 squared. B squared equals 51.2 squared minus 28.8 squared, and you need to take the square root. B is plus or minus the square root of 51.2 squared minus 28.8 squared, and of course we're taking the plus because B is the side of a triangle. So again, once we have 2 sides, we can get the third side. This is again analogous to the fact that once we had 2 angles, we can get the third angle. What is that roughly? 42.33.
All we got to find was C. I mean B for this one.
No, B was just the easiest one to find.
Okay.
That's why I just did that one first. Yeah, we'll do A and B in a second. Okay. So it doesn't matter which one you want to do, A or B.
B.
You want to do B? I was actually wanting to do A.
We can do A. Come on then.
So A. So A, I don't know what this angle is, but I do know I can relate this angle to 2 other sides I know. What angle relates A to this side that I know and this side that I know? Sine, right? So sine is the opposite over the hypotenuse. Now look, we might like our game and say, well, why don't I use B? I just found it. Well, you might have made a mistake. So let's just go ahead and use the ones that were given, right? So you might want to say, well, let me use B and use tangent and do this over this, right? So just use the ones that were given just in case you made a mistake for B. So sine of A is 28.8 over 51.2. Right? I'm looking for A. Well, I know how to get A. A is the, how do I drop this sign? What do I do to both sides?
Divide.
I am going to divide, but in a funky way. I'm going to, so if I had 3x equals 9, right? I would divide, or I would bring the inverse of 3 into play, right? Here I need to do the inverse of sine. All calculator, inverse sine of 28.8 over 51.2. What are inverse trig functions again?
Angles.
Angles. Oh my goodness. I'm looking for, A is the angle, right, that I need in order to get the sine of it to be that, right? That's all calculator. Let's test that out. Again, you're pressing second sine, and then you'll get an inverse sine, and then 28.8 divided by 51.2. One decimal place, 34.2.
Go back to the degrees. Go back to degrees on this one. Oh,
It's a triangle, always degrees.
Alright.
Yeah, stay in degrees for triangles. Go ahead.
So you went like, from top, from 1/3 in each one?
No, I was just demonstrating that the idea of applying the inverse remains the same whenever we're solving for x. To get rid of the thing that's sitting and holding x in, you apply the inverse. Whether it's 3x and you divide both sides by 3, all you're doing is bringing in 1/3 the inverse to cancel it out, right? So when I have a stuck inside of the sign, to free a, I do the inverse sign on both sides, right? And it gets a to be free, and then the other side has an inverse sign on it, right? Questions about how to put this in your calculator? Inverse sign, second sign, and then you put it in, and then it gives you, of course, inverse trig functions are angles. It's going to give you an angle back. We could do something similar for B, but again, we have 2 angles. We can easily find the third angle. 1/8. So we got 90 already, right? We got 90, 34.2. B is 180 minus 90 minus 34.2. B is whatever's left over. Capital B is whatever's left over. 124.2, 45.8. 45.8 degrees.
Degrees.
Degrees. Is it 55?
55.8.
I think it is 55. Yeah.
No, it's 45.
All right. I'm trying to trust you all. 124.2.
It's 55.
Just 55.
Thank you, brother. 5.8. I might as well be here by myself. You know, I was going to keep being wrong. Just do the whole thing by myself. Questions about this? How bad is this get? .8. Scrolling down. All right, terminology. Find the bearing. This is just new terminology that comes up in word problems, okay? So here's the notation. This here, I'm going to say that I'm going to start off by referencing either north or south. This is an angle that's being made with the north, right? So this would be north, and then I'm moving east. And the question is, how many degrees have I moved east? Right? How much is it?
15.
Yes, we are struggling today, all of us, with arithmetic.
Sorry.
Okay,
How you got 15? How you got 15?
thank you, I appreciate that. That whole angle, northeast, is 90.
Oh, so 75 minus.
Right, it's 90. So that vector, right? That vector is moving on a heading of north 15 degrees east. North 15 degrees east. Okay. So you start off with north-south, and the second direction is east-west, right? And again, we're bringing this up only because they like to write word problems with this terminology. Okay.
So you always have to start with north or south.
It's north or south, yeah, that's reference to north or
Just
south.
go which direction.
That's right. Similarly, for number 5, south,
West.
To west,
south, yeah, that's right, but how many degrees?
10.
That's clearly, it's
80.
directly 80, yeah. So it's south, 80 degrees west. South, 80 degrees west.
Does it be on the test?
No. Let's get right to it. But yeah, no, but this is going to be in the future homework problems later on, right? Because it's going to say boats moving, what does it say? Boats moving however many degrees north, this many degrees west, right? I think the last problem says that on the homework today. So,
I only seen one homework. That's correct.
5.8?
Yeah.
That's it. It's the homework and then the practice test. Okay, so yeah, so this one is south, 80 degrees, going west. All right, an object is attached to a coiled spring. Say it again?
You should make yours a little.
Absolutely. Yeah, an object is attached to a coiled spring. The object is pulled down in the negative direction. So, so you got some spring, right? Got some object, right? It's at rest. You pull it down 8 centimeters, okay, and then released. Write an equation for the distance. So then what happens? You pull it down and it just starts doing this, right? This goes up, down, up, down, up, down, right? And when you measure the height, it might look like this, right? It might look exactly like that, right? So it's going to go above where the resting position, below the resting position, and so its up-down movement over time, right, looks like a trig function. So spring mass functions in physics are used trig functions for this reason. Okay, so again, this homework is all about word problems. Okay, so now we have, I apologize, I don't have Desmo set up already. We don't really need it. So this one is saying the object is pulled down in the negative direction 8 centimeters, then released. Write an equation for the distance of the object from its rest position after t seconds if the amplitude is 8 centimeters and the period is 4 seconds. So the question is, we've got d equals, and the answer has to be d equals something. D equals a sine bx. In this case, they're using t, right? A sine bt, or d equals a cosine bt. It's one of those two, right? And we know from last week that, what's a?
8.
Is it 8? Is it 8? Okay, so it's not 8. It's negative 8 in this case.
Oh, yeah. There you go.
Okay. All right, so we're going to pull it. It's going to start off at the negative direction. So what does this mean? This means that your trig function, if it measures the distance, is going to start off down here. Cosine starts off, if it was positive 8 cosine, it would start off at the top, right? So simply because you're going to pull it down and start it off at the bottom, right, then it should be negative 8. And so I've already implied that if it starts off in the negative direction, then it couldn't be sine. Why? Because the sine goes through the origin, right? So this one is negative 8, the cosine of something times t. And now we need to find out what it is. Well, we know the period. The period is 4 seconds, right? But we also know that the period is 2 pi over b. Okay. Right, so then we switch. 2 pi over b equal, 2 pi over 4 is equal to b. Okay. B is pi over 2. Negative 8, d equals negative 8, the cosine of pi over 2t. That is the function. So, yeah. Questions about that? So the wording, again, we're working word problems today. The translation mathematically, they give you the amplitude is 8 centimeters. We know that that's the thing in front. We know it's negative because we started having been pulled down, and so then we can just run it from there, right? The period we know is 4 seconds, but we have the formula for the period is 2 pi over b, set them equal to each other, solve for b, and then b is the coefficient of t. 7 uses sine, right? And an object is attached to a cold spring. The object begins at its rest position, so that means nothing. It starts off at 0. That's screaming to you there that you should be using the sine function, right? So the fact that you're starting at rest position means that it's a sine, so we're using a sine of bt. And so it is then propelled downward. Write an equation for the distance of the object from its rest position after t seconds. The amplitude is 8 inches and the period is 3.5 seconds. Questions about that? So then what's A? A is still -8. How do I know it's not +8?
Because you pull it down.
It's pulled down, right? The sine in its original sense goes up like this. Sine, it looks like X through the origin. This one's being pulled down. It wants it to look like this, which means that the coefficient has to be negative, right? So downward means that A is negative. -8 sine of bt. We know that 2 pi over b needs to be 3.5, right? Funky. I tried to put this in my math lab. They don't like it. So they don't like 2 pi over 3.5. You know what they said. Although your answer is in the correct, blah, 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 blah. So we need to change this to make this a fraction. I'll multiply both the numerator and the denominator by 2. That's 4 pi over 7. Okay, it makes it a nice fraction they like. -8, the sine of 4 pi over 7t. Questions there? So so yeah, these are the ones that are final like, right? Where it's saying, here's the situation, write the trig function that models this situation, right? So as we prepare for the final, we'll go over these again, obviously, but just keep in mind that that's definitely a final question. Here, we'll give some, again, all I'm here to do is translate, right? So now, an object moves in simple harmonic motion, so now you got some object that's moving along this wave, and so we can say some things about how this object is moving, right? So it moves according to this. The maximum displacement, that of course is just the absolute value of 5, right, which is 5. Right, so all that means is from its resting position, displacement means how much have you been displaced. What's the farthest away from its resting position that you can get? Obviously that's 5 up or 5 down, either way it's 5, right? I really hate the order in which they do this. So when they do the frequency, let's make this clear, the frequency is inversely proportional to the period. The frequency is 1 over the period. Right? The frequency is how often in cycles per second are you repeating, right? So usually I do the period first, and then I'll go back and do the frequency. So they never say period. They say, what's the time required for one cycle? This, of course, I'm just here to translate. We know that that's the period. The period is the length of time it takes to repeat, right? So they say, what's the time required to go through one entire cycle? That's the same thing as the time required to start over again. That is the period. We know that the period is 2 pi. Oh, I'm sorry, what's b in this case?
1.
What's b in this case?
2 pi.
This is 2 pi, right? So b is 2 pi. The period is thus 2 pi over that b. We know that b, of course, is 2 pi over pi. This is repeating every second. Right? 1 cycle per second. If it's repeating, if it goes through an entire cycle in 1 second, then that means we're doing 1 cycle per second, right? That's the frequency. Okay. So just terminology, right? So, hit number of problems. Something like that. An object moves in simple harmonic motion described by this, where t is measured in seconds and g is in inches, fine, the same thing. So it's all the same thing. I'm probably going to leave that one to you to do. Same exact thing. Okay. Hardcore.
2 seconds.
Yes, I can. Hardcore word problem for number 10. I'll copy this one. We good?
Yeah.
Okay. So then. I should have just taken the triangle, but that's okay. We're looking for x. Want to be clear about something? They say do not round until the final answer. There's a numerical analysis issue there. You start working through this, you are working with all these numbers, right? All these fractions. You round at any moment before the end. Oh my goodness, you take a rounded number and then you start doing stuff to it. Take a rounded number is already not the exact answer. You keep doing all these operations to something that's wrong, it gets more and more wrong, right? So let's not round until the very end, right? They already want us to round to the nearest whole number, but every time we take a fraction, or every time we take a rounded number, the earlier in the problem, the more you do stuff to it, the more off from the real answer you get. Okay, so just be careful to not round until the very end. You're going to be tempted to round, obviously, because you're going to have the cosine of something is this, and you want to put it in your calculator. It's going to have a ton of decimal places. You're going to want to round. Do not round until the end. All right, so we need to find x, and it looks like x is clearly the sum of 2 triangles, right? So if I found this side and found this side, I can just add them, right? So I can call this Z, I can call this W. I'll find W and Z, and then I'll add them at the end. Right. Let's find Z first. Z is the opposite side to 40 degrees. It looks like they gave me the adjacent side. What trig function is that? Tangent. It's not the hypotenuse, so it's got to be tangent, right? 44 degrees equals the opposite over the adjacent. Z equals 540. We better be in degrees, right? Tangent 44 degrees. W looks pretty similar, right? For the same reason, W, let's just say it the whole way, the tangent of 20 degrees is equal to the opposite, W, over the adjacent. W is 540, tangent 20 degrees. Calculator, add those 2 rounds to the nearest whole number. Just read 4 out.
Yep.
Good. Which one's 72? The whole thing? The whole thing. Just, yeah, you can just throw the whole thing right in the calculator. TI looks like 540 tangent 44 plus 540 tangent 20. Just end it one whole line and just, it's over. And it's 70 even, whole number?
718.
718? Okay, 718. That's a whole number. All right, so just verify that that's 718. Again, makes sense? All right. Oh, thank you. Go back. Where was that? Was that here? Here? Maybe it was here. Something. Oh, while I'm here, I started to include IDs, right? So if you go into study plan, right, and click on chapter 5, section 5, chapter 5, section 8, and go into the study plan and click on problem 29, you'll see this problem, right? And you can just practice as often as you need to. Okay, so that's the ID. We good? Thank you. All right, so then another one. So we're being nice. We're going to give you some pictures. And then 12, we won't give you a picture. Those are the classic ones that we'll run into. Right, so there's the picture. All right, questions. What's X? So what's the game plan for this one? Trying to get X by itself, where it looks like 34 degrees is the angle for the whole triangle. It looks like we can get the entire adjacent side. And for this triangle right here, it looks like we can get this adjacent side, and of course then we would just subtract, right? So we get the length of the whole triangle, the base of the whole triangle, we get the length of the smaller base of the smaller triangle, and then we'll subtract those two numbers. So then the idea is to get this whole thing, Z, we'll get this little piece, W, and X, of course, is the difference in the two. All right, so we got, so for this triangle here, we're talking again about people just don't want to ever give us the hypotenuse, right? So again, here we go, tangent 34 degrees is the opposite, 350 over Z. Switch, Z is equal to 350 over the tangent of 34 degrees. It's all calculator. And then for this smaller triangle that I'll put in red, for this smaller triangle, we want to get W. 60 is actually on the unit circle, I really don't care. So the tangent of 60 is 350 over W. Switch, W is 350 over the tangent of 60, calculator, and then you subtract those two numbers. Right. So yeah, this should be becoming redundant. It is simply my job that when you arrive at calculus and you hit these triangle issues, you just know exactly what to do, right? My brother or sister who's going to be teaching you calculus, they're going to say, well, who did you have for pre-calc? And you're going to call me out, and then I know what some of you are going to do. Well, you never went over that. You know, it's just throw me under the bus, right? It's all good. I don't remember going over that, right? So you won't say that about triangles, right? So we got 6 more to go. You should be like, okay, I'm tired of doing these triangles at some point. We got a whole homework of doing it. I hope I'm hammering home the point. Questions about that? Okay. 5, 8. Oh yeah, so now no picture. So the first thing we're going to do is we're not afraid. We know that this is a question about a triangle, and now they're just saying you need to write it yourself. This is the one that is on the test. It looks very similar to this. I have minimal to say for the moment. Try and do this one, as this is the one. It's ID 5.8.41. It's the one on the practice test, and so it's going to be very similar to the one on the real test. So I'm going to let you try this one while we have it. Draw a triangle that fits this situation. Of course, one of the sides will be missing. You need to use the trig function to find it. Yeah, I may not even finish this one. Yeah. point on the level? No, so this tower is standing up. You are a mile away from it, and you're looking at it. So we don't know how tall the thing is.
Okay.
We have no idea how tall it is. It's standing up. Somebody is a mile away, and they're looking at it at a particular angle. So good, this is good. So the tallest television tower is in North Carolina from a point on level ground. So they're saying not how far you're looking. If the tower and you are on level feet, then you're 5,200 feet away from each other on the ground. On the ground.
Sort of up, but I heard you say looking at it sounds like.
Yes, oh no. I like it. Put 5,000 somewhere. 5,280. It's there.
Right here?
Yeah.
Okay.
So the person, so relative to the tower, the person is just like a little point. So there's the person, there's the tower, and they're telling you the looking angle is that. So that the angle they give is that, and then you're looking for that height.
Okay.
What was the picture? Thanks, man.
Oh, the picture.
Yeah. It's funny to see when people are using the triangle pointing to the left or the right. That's perfect. Solid. Solid. I love it. That's good. Solid. That's your function. You're looking for this. You're looking for the height. Yeah, that's great. You're looking for the height. Use the trig function. That's perfect. Good. Yeah, that's, this is the angle,
Yeah, that's an angle.
and this is the distance, right?
Yeah.
That distance is here.
So the bottom.
Yeah, because it means that from on the ground, the distance is a mile. Good. I saw some of your papers. Looks like everyone's got the right picture. I'm gonna leave this to you. So somebody's looking up at this angle, this many feet away from the base of the tower. We want to know how tall the tower is, right? And so again, because of our ability to make angles are so powerful, right? So without even we can be a mile away from the place, and then we can calculate the angle, and then we can figure out the height of the tower without it actually even being there. Right? It's pretty nice. Okay, great. And then solve. Looks like, shockingly, tangent. Okay, so 12, 13. Problems like this come up in calc all the time. You got some triangle or some plane flying overhead at some rate. You almost don't even need to know the story. We're looking for D. Okay, so a helicopter hovers 1,075 feet above a small island. The figure shows that the angle of depression from the helicopter to the point P is 34 degrees. That makes this what? 56 degrees. And it's over. Right. So again, tangent. We're looking for how far is their point on the ground from P. And so we're talking about the tangent of 56 degrees is equal to the distance we're looking for over 1,075. D is 1,075, the tangent of 56 degrees. Round to the nearest whole number. On a calculator. 14, got a ramp. Try and draw this picture. A ramp is to be built beside the steps to the campus library. Find the angle of elevation of the 21-foot ramp to the nearest 1/10 of a degree if its final height is 4 feet. So we got something like this. Ramp goes up, right? Final height of this ramp is 7 feet. I'm sorry, 4 feet. 4 feet. The whole ramp has a length of what? 21. Trying to find out what angle it has to make. Right, so we're looking for that. Okay. Looking for the angle. Trig function? Sine. Y, opposite, we got. Hypotenuse, we got. Sine of the angle is equal to 4 over 21. And then we apply the inverse sine. Inverse sine of 4 over 21. All calculator. As we would expect. I mean, sine functions are just ugly, right? They're not going to be nice. Why? Because they involve pi, right? They involve this thing, right? So it's irrational. All these numbers are going to look ugly, so we're going to be rounding to the end of time, okay? Inverse trig functions are angles. Make sure, again, you're in degrees.
How many questions are there?
On this homework?
Yeah, how much are we gonna do? It's whole thing.
Oh, so it's 17. The 17 problems on this homework. We'll take a break and then we'll go over the practice test.
How many questions?
Practice test? 25.
25 questions on the test.
Yep. Okay.
Oh, so we're going over the practice test in class?
Yeah.
Alright.
Oh, somebody's interested now. Let's do it, right? 15. I may leave this one to you. Let's see here. We know the deal, right? We got this whole 2 triangle problem. Number one, of course, no matter what the story is, we're not intimidated by any of this nonsense, right? So we know when we're given a triangle and enough information, we can find out all the stuff we need to find out, right? A hot air balloon is rising vertically. The angle of elevation from a point on the ground 125 feet from the balloon to a point directly under the passenger compartment changes from 16 degrees to 29.5 degrees. How far has it gone up when it's gone from 16 to 29.5? So we need to find the change in the distance, as you might expect. We're going to find the length of the entire triangle. We're going to find the length, rather, we're going to find the height of the bigger triangle, the height of the smaller triangle, and simply subtract. Same idea again, right? So for this larger triangle, we're talking, well, I shouldn't use black, it's already in black, right? So for this larger triangle here, we're talking about wanting to find this distance, the whole distance, we can call it Z. And so again, that's tangent of 29.5 degrees is equal to the opposite over the adjacent. Z is 125, the tangent of 29.5 degrees. And then for the smaller triangle, we'll put in green we're looking at, that's W. Then we're talking about the tangent of 16 degrees is equal to the opposite over the same base, adjacent side. And so W is 125, the tangent of 16 degrees, and you add those two numbers, right? What in practice, 5.8 and 49. You're subtracting those two numbers, yeah. And that'll give you the difference. Couple more. A boat leaves the entrance to a harbor and travels 125 miles on a bearing of north 58 degrees east. How many miles north and how many miles east from the harbor has the boat traveled? Draw that picture. A boat leaves the entrance to a harbor and travels 125 miles north, 58 degrees east. How many miles north and how many miles east from the harbor has the boat traveled? Looking for the X and Y coordinates. Right. Oh, I don't want to use green. Let's use black here. So then we've got this thing. I want to put the entrance of the harbor. I want to put that at the origin. So it travels north 58 degrees east. So we're talking about that, right? What's this angle right here? 58 degrees. Okay, is that okay? Questions there? And what's the distance?
125.
125 is that hypotenuse. It's this triangle I'm interested in. Is that okay? Can you tell me anything about some of these angles? You know this angle right here? 32 degrees. And we're looking for these distances. How far to the right have I gone? And how far north have I gone? Right? So I'm just looking for, I'm looking for both of these. I can call this X and I'm looking for X and Y. And we're just going to trig function it up, okay? And we're straight up using sine and cosine. Right? Which one you want to solve for first, X or Y? Y. So as you might expect, the sine of 32 degrees is going to give us the Y coordinate. It's Y over 125. Y is equal to 125, the sine of 32 degrees. This is very much related to polar coordinates. In order to figure out the X coordinate, you need the cosine. The cosine of 32 degrees is equal to the X coordinate adjacent over the hypotenuse. X is 125, the cosine of 32 degrees. And so this is, when you round that, this is the amount east in miles, and this is the amount north in miles. And you put that in the calculator and round to the nearest tenth of a mile. Right? So the only thing really in terms of doing these problems, particularly on the test, is just be super careful in terms of what my math app's going to ask. They, unfortunately, for the problems that you'll see, somewhat inconsistent. Sometimes we ask you for the whole number, sometimes we ask you for a tenth, sometimes we ask you for the nearest hundredth. Just be very clear and methodical about the decimal place rounding, right? So, yeah. Okay. 58, 32. Yeah. And then finally, I think we can see that. We can make that a little larger if we want. View 150. Okay. A forest ranger sights a fire directly south. A second ranger, 7 miles east of the first ranger, also sees it. The bearing from the second ranger to the fire is south 20 degrees west. How far is the first ranger from the fire? Draw that triangle. Just telling you at the start. So in a lot of ways, when they talk about this first person, that person should be at the origin. Everything's in reference to that person. So put the first one down there. South from that, the fire's raging. East from him, there's some stuff going on with another ranger, right? Looks like you got three things. There's your triangle. And now they're trying to tell you something about the angle. Okay. Ranger. First Ranger. Fire. Seven miles east. Of course, we're looking for that. Second Ranger's here. How does this angle show up? South, well, let's just draw it. This is the triangle we're interested in. Does it work out nicely? What is this angle? Straight up 20. It is south, is it? 20 degrees west. What's this number? 70. Okay, be careful. South, 20 degrees west is this angle. It's really the 70 we're looking for. And it looks like it's tangent again. We'll break there. We'll come back, do the practice exam. We'll break until 7:45, 10 minutes. We'll do the practice exam and then we'll call it a day.
So,
We'll be over in the,
what would be the answer for that?
how many of these have we done, right? Let's do it.
Oh,
So then the tangent of 70 degrees equals x over 7. X is 7, the tangent of 70 degrees. Plug that in the calculator.
could say around 7 minutes. Oh, no.
Yeah, what'd you put in the calculator? Yeah, put it in the calculator and then it'll tell you what's your name. Yeah. Okay, we're on break.
I can leave that, please.
Yeah, I'm just pausing the recording.